All right, class. In this video, we continue our discussion of section 4.5 in your textbook on solving exponential and logarithmic equations. So we're starting on page 2 of your lecture handout. And on this page, we're solving an exponential equation of a little different type than what we did on page 1. Here we're going to solve the exponential equation 8 times e to the 2x power is equal to 20 for the variable x. What number can we put in for x in the exponent here? And when we do the arithmetic, the left-hand side is equal to 20. Well, the first step thing you want to do in an exponential equation of this type is to isolate the exponential on the left side. So we have 8 times e to the 2x. And e to the 2x is the exponential. So what undoes multiplication? Division. So we divide both sides by 8, and we get e to the 2x is equal to 2.5. 20 divided by 8 is equal to 2.5. Now we've isolated the exponential on the left-hand side. So one technique for solving an exponential equation involving the number e is to take the natural log of both sides, right? E, the left-hand side equals the right-hand side, so the natural log of the left-hand side has to equal the natural log of the right-hand side. So we make e to the 2x the argument inside the natural log function on the left, and 2.5 the argument inside the natural log on the right. Okay, since these are equal, these have to be equal. Well, from one of the properties of the natural logarithm from section 4.3 says if you take the natural log of the number e raised to any power, then the natural log and the e essentially cancel, and you're left with that exponent 2x. So we're taking the natural log of e to the 2x. So by one of the properties of the natural logarithm from section 4.3, the natural log and the e cancel, and we're just left with 2x on the left. And that's equal to the natural log of 2.5. And the natural log of 2.5 is a number on the real number line. If you type into your calculator natural log of 2.5, you'll get a decimal number. Well, now it's solving for x, right? You just got to divide both sides by 2, and we get x is equal to the natural log of 2.5 divided by 2. This is the exact solution to this problem up here, original exponential problem up here, right? You put in a natural log of 2.5 divided by 2 in for x up here, and the left-hand side will equal 20. To find the decimal approximation to this problem up here, right, use your calculator, type in natural log of 2.5, hit enter, you get a decimal number, divide that number by 2, and you get the value of x that's for the solution to the problem up here to 6 decimal places is 0.458145. All right, so this is one way of solving this problem up here. I'm going to show you a second way of solving this problem, and you can always choose the method that works for you. So again, we have the same original equation, 8 times e to the 2x is equal to 20, and again we want to isolate the exponential on the left side. So we divide both sides by 8, right, because that's 8 times e to the 2x. So we divide both sides by 8, and we get e to the 2x is equal to 2.5. Now, instead of taking the natural log of both sides, we can go from exponential form here to logarithmic form down here. So remember, e is the base, and 2x is the exponent. And remember, logarithms are just a fancy way of expressing an exponent in an exponential equation. So the exponent is 2x, and that is equal to log base e of 2.5. So this is what I got right here. 2x is the log base e of 2.5. Well, log base e, right, the notation ln just replaces log base e, right? Remember, log base e gets its own notation, and it's ln for the natural log. So 2x is equal to the natural log of 2.5, and then we divide both sides by 2, we get the same exact answer as up above here. And then when you do the use your calculator, you get the same decimal approximation as up here. Okay, so you'll notice the decimal approximation from the first technique is the same as down here.